Hello everyone, this is the second lesson recording for IM1, December 15th, 2020. So now we're going to continue with the PADEC. Okay, so this time you're given an equation and you're going to convert it to slope and y-intercept. If you're given an equation, what is the slope, what is the y-intercept? Slope is always the number that is being multiplied to the variable, right? So in this case, y is the output, the input is x, so it is the number that is being multiplied to x. So it is just the number. Some of the students are telling me it's negative 3 over 2x. There's no x there. So it's negative 3 over 2. And what is the y-intercept? Y-intercept is the number that does not have the variable multiplying to it. So that's going to be negative 2. Okay, this time you need to figure out what the slope is and the y-intercept and then finally the equation. Okay, so what is the slope? To do that, you need to draw your slope triangle. So you're going from this point down to the next point. You're going down. Going down means delta y it's going down by 1, 2, 3, 4. So it's going down. So it's negative 4. While as you're going to the right, so delta x it's going to be positive because you're going to the right and it's going by 3, so it's going to be delta x is going to be 3. Slope is always delta y over delta x, which is negative 4 over 3. So I know the slope is negative 4 over 3. Now, what is the y-intercept? Y-intercept is where the graph crosses the y-axis. Y-axis is, this is my y-axis. Okay, so the y value when the graph crosses is negative 3. So it's going to be negative 3 is my y-intercept. So the equation is going to be y is equal to, the slope is negative 4 over 3. And then don't forget the x, and then minus 3. That's going to be my equation. Okay, next up, we're going to go from the table to equation and also to graph. Okay, so when you are given this table of information, below is the data collected for Bryant in his bike race. So when at time 2 seconds, his distance in meters were 2 meters. At time 6 seconds, 14 meters, and when time was 10 seconds, he was 26 meters from the starting line. So what is his speed? What is his starting point? So to figure out the speed is the same as the unit rate or slope. So in this case, slope is always delta y over delta x. In this case, the input is the time, so that's like my x. The output is the distance, so that's like my y. So on the graph, I can say the x-axis is going to be the time in seconds, and the y-axis is going to be my distance in meters. Okay, so that's my distance and that's my time. So delta y over delta x, to figure out how it is changing, we need to figure out how is the y value changing or the distance. 2 is changing to 14, and then 14 is changing to 26. What is being added? 12 is being added. How do I figure that out? 14 minus 2 is 12. 26 minus 14 is 12. So we are adding 12 to the y when x is being added by 6 minus 2 is 4 and 10 minus 6 is 4. Remember, slope is delta y over delta x. So that's going to be 12 over 4, which is, don't leave it as 12 over 4. Simplify the fractions whenever possible. 12 divided by 4 is 3. So it's a positive 3. Now, to figure out where is the starting point from the table, we need to figure out what is, when time is equal to 0, what is the distance? So to do that, we need to go back by 2. Okay? And now when we go forward by 4, we added 12. So when we go back by 2, that's half of 4. You have to subtract 6, don't you? Instead of adding 12, half of 12 is 6. But instead of adding 6, we need to go backwards. So we are subtracting 6. So subtracting 6 from 2 is going to leave me with negative 4. So this tells me the starting point when time was equal to 0, his position was negative 4. While it's Brian's speed, so negative 4 meters. And what is his speed? Speed was 3 meters per second. Okay, so and if I was to try to graph this, I can go from the table to graph by the x coordinate is 2, y coordinate is 2. So find 2 on the x and find 2 on the y. 2 is going to be somewhere like this. The next point is 6, comma 14. Find 6 on the x, 14 on the y. It will be somewhere like this. And then finally 10 and 26. Let me move that. Okay, 10 and 26 will be somewhere like this. Okay, so that means if I was to draw my line that goes through these points, it will look something like this. Okay, so where the slope is, remember this point was the middle point, so that's 6 comma 14, and this was 10 comma 26, and I can figure out the delta y. It went from 14 to 26. So 26 minus 14 is going to be 12 here. What about delta x from the graph? It went from 6 to 10. So 10 minus 6 is 4. So again, I get from here, the slope is delta y over delta x. That's 12 over 4, which is 3, which is what I have here as well. Okay, and the y-intercept, it's not very, because I'm not drawing a very straight line, this does look like it should be negative 4. What does negative 4 meters mean? He actually started 4 meters behind the starting line. That's what that means. Okay, so this one now asks you to, when do we use distributive property? We have two different problems. One you're going to use distributive property and one you're not going to. So please pause the video and see if you can figure out. Okay, on the left-hand side, remember when you have parentheses, you always try to evaluate inside the parentheses. In this case, are we able to do that? 9 minus 4, can we subtract 4 from 9? Yes, that just becomes 5. So the expression just becomes negative 3 times 5 plus 2.9. 2.9, this is not 2.9, this is 2 multiplied by 9, that's 18. So that's negative 3 times 5 is negative 15 plus 18. That leaves you with positive 3. So 3 is my final answer. What about this? Now, can we evaluate what's inside the parentheses? Can we do x minus 4? No, we cannot do that because x and negative 4, they're not like terms. So we cannot combine unlike terms. So that means the only thing we can do is we can distribute this negative 3 being multiplied to this parenthesis. So you can distribute negative 3 being multiplied to x, the first term of the inside the parenthesis, and then add that to negative 3 multiplied by negative 4. So that becomes negative 3 multiplied by x is negative 3x. Negative 3 multiplied by negative x. Notice that that negative sign belongs to the 4. So you're multiplying negative by negative. So that's going to be positive. 3 times 4 is 12. And then we still have to add 12 to x. And then that is equal to 18. So how do I go about now? I have to combine like term. Always combine like term within the one side of the equal sign first. Negative 3x and 2x gives me negative 3 plus 2 is negative 1. So negative x plus 12 is equal to 18. Then from here, I need to subtract 12. And that leaves me with negative x is equal to, what's 18 minus 12? That's just 6. Okay, now, but I don't want negative x to be some value. I want x. So how can I get rid of this negative sign? Remember, negative sign just means -1 is being multiplied to x. So I can divide both sides by -1. So then this becomes my giant 1 and cancels out. And so x is equal to 6 divided by -1. So that's just -6. My final answer is -6 here. Okay, so the last problem is multiplying 3x minus 2 multiplied by x minus 3. This is the area model where this is the length, oops, and this is my width. So you're multiplying 3x minus 2 multiplied by x minus 3. So I can put 3x minus 2 here, and then x minus 3 here, and then we are actually multiplying. Okay, don't forget, we are multiplying. The operation is multiplication. So 3x times x is 3x squared. -2 times x is -2x. And then 3x times -3 is -9x. And -2 times -3 is +6. Okay, so now we have this is equal to, okay, we have to add all the different parts. That's going to be 3x squared minus 2x plus 9x, oops, minus 9x plus 6. Now, I can combine like terms because -2x and -9x are like terms. So we still have 3x squared here. And -2 minus 9 is -11, -11x plus 6. So this is my final answer. So it's going to be 3x squared minus 11x plus 6. Okay, now the final card is where you get to move the bar, this pink bar, according to where you feel, how confident you are. If you are, I've been working hard and I feel pretty confident, you're gonna move your pink bar over here somewhere. And to the other extreme is, I don't feel ready for the finals, I need help. You're going to be putting yourself here. This is a chance for you to reflect on how well you feel that you are prepared for the finals. Okay, that's it. So again, remember that I am available for you if you need any help. I'm going to be in my study hall till 4 o'clock, Tuesday, Wednesday, and Thursday. So please come see me. Thank you for listening. See you later.